Hello, grade 11s. This is Miss Cancelon again. You will need to have a geometry set for this lesson, so make sure if you need to pause this video and make sure you have a full geometry set. That is what you will need. Okay, so we're looking at 2.2, angles formed by parallel lines. Hopefully you're following along in the textbook. We're going to prove properties of angles formed by parallel lines and a transversal and use these properties to solve problems. Okay, this word here, prove, means we're probably going to be looking at 2-column proofs. And what kind of reasoning are we going to use? Somebody put up their hand to tell me what kind of reasoning. Anyone? Anyone? Hopefully we're going to use deductive reasoning. And I know you all shouted that out, which is wonderful, but not shouted because the grade 12s are working. Okay, so first of all, to start off, parallel bars are used in therapy to help people recover from injuries to their legs or spine. How could the manufacturer ensure that the bars are actually parallel? I would like somebody to come and press pause, and I would like you guys in partners to have about 1 minute to discuss what you could do, the manufacturer could do to ensure that the bars are parallel. Okay, hopefully we actually did press pause. We're going to see if any of you guys came up with these or maybe even better answers than this. So solution 1, install one of the parallel bars. Place the second bar in an approximate position and then place another straight object, such as a meter stick, across both bars. Measure the angles, the corresponding angles formed by this transversal, and adjust the second bar until those angles are equal. Check for accuracy by moving the meter stick to a different position and intersect at a different angle. So they're putting a transversal and checking that these angles are the same. Solution 2, the manufacturer could provide a paper template with the parallel bars. The template would indicate the placement of the bars and location for the supporting feet of the bars. The manufacturer could ensure that the template is correct by drawing a set of bars, drawing that same transversal, and then measuring the corresponding angles to check that they are equal. So then if you had this giant piece of paper, this giant template, you would just have to line up your bars on that template. And finally, this is what I would have thought of. Install the first bar, make sure it's the same distance from the floor in several locations. Using a tape measure, install the second bar, ensuring the distance from the floor to the bar is the same as the first bar in several locations. Measure the distance between the two bars and adjust so this distance is the same. So just making sure that the distance between two parallel lines is always the same, that distance being the same. Good. Okay. This is going to be an activity we're going to do, and you guys are going to do much better than I am because you have real geometry sets, whereas I'm going to try and do this on the smartboard. So this is in your textbook, but I want this in your notebook. I want you to go step by step on how to draw parallel lines. So step A, you should write step A. Draw the first line. Place a point P above the line. P will be a point in a parallel line. So when we're drawing lines, we need to make sure we have a ruler. You need to bring your ruler down. Ooh. See, you guys are much better. You can move a ruler easier than I can. You're going to make a ruled line, and you're going to put a point P somewhere above that line. Next, you're going to take your ruler and pause me because I'm probably going faster. And you are. No, now you're not going to move the way I want you to, ruler. Oh. You're going to draw a line through P, intersecting. Please, ruler, work. Oh, there we go. I'm going to draw a line through point P that intersects the first line that we drew, and we're going to call that point Q. It doesn't matter if you have drawn something and your line's like this and it goes like that. Doesn't matter. Same process, okay? So that's step B. Draw a line through P intersecting the first line at Q. Step C, using a compass, construct an arc that is centered at Q and passes through both lines. Label these points R and S. So this is where your compass becomes much easier than mine. Do I have a compass? No, I have two compi. That's That's plural for compass, if you guys didn't know. I'm totally kidding. Okay, so we're going to put it at point Q, our compass at point Q right here. I am going to open up, no, I'm going to open up my compass just like that. And now I'm going to draw an arc. See if this works. Yes, I'm going to draw an arc. This arc has to go through the first line that you drew and that second line that you drew, and then we're going to label those points R and S. We're going to keep this same opening on our compass. I want you to draw another arc on point P with the same radius. So that means we haven't changed how wide our compass is. I'm going to bring this over here. We're going to put it at point P. So it's really good. I didn't mention this, but you wanted your lines to be long, like this line we drew, this transversal we drew right here. It's always good to make the lines a little long so that these arcs have spaces to go. Okay, so I'm trying my best to put that right on point P, and you guys will be much more exact than I am. And we're going to try and, no, we're going to draw an arc. Oh, look at that beautiful arc. And where that arc, I'm going to make it even bigger because this is so fun. Where that arc intersects the transversal, we're going to call T. So that's step D. And feel free to pause when I'm going too fast, guys. Draw a third arc with center T and a radius RS. So our radius is R to S, so we have to come onto our diagram here. We have to put on R. We have to rotate, oops, move on R. See if I can do this. So I want to rotate. First of all, I want to rotate this. Will you let me rotate? No. I won't. Oh, I bet this will let me do it. Okay, there we go. Okay, I want to put on R. I want to get a radius of RS. Oh, jeez. So you guys have probably done this in 2 seconds. Okay, a radius of RS. Not quite perfect. There we go. And now from RS, I put that point on T. I put, sorry, my compass on T. As exact as I can. And now I'm going to draw another arc that's going to, oops. That's going to intersect the arc I made in the last step, right there. Oh, beautiful. So that's step E. Draw a third arc with center T, a radius RS that intersects the arc you drew in the last step. Label this W. So we're labeling that W. Now we're going to draw a line that passes through P and W, and we're going to show that PW is parallel to QS. So to draw a line, we will need a ruler. I think I had a ruler up here. If it will move with me. Thank you. So I have my ruler. I'm going to draw my line. I'm going to connect point P and point W. P and W. And I'm going to draw a beautiful line there. But now it says we need to show that PW is parallel to QS. The way we're going to show that, that symbol means parallel, is we're going to actually take a protractor, compass, I always get those words mixed up. We're going to take protractor, we're going to actually measure some of the corresponding angles, because if those corresponding angles were equal, then we would know that these lines are parallel. So I'm going to line up right here, I'm going to see that this is just over 60 degrees, and you guys will be much more exact than I just was. And this one here, this corresponding angle is also just over 60 degrees. Very good. Okay, and so there's lots of corresponding angles you could check. You want to check that these angles are the same. You want to check that those angles are the same. Lots of different relationships that you can check to show that those PW is parallel to QS. Okay, so this construction comes into play in one of the questions you have to do in this section. So it is important that you did this construction and you understand those steps. It is in your textbook as well, but hopefully you did it in your notebook and you'll have that to look at. So what we're going to do now is we're going to follow along some conjectures involving angles formed by transversals. So it says make a conjecture that involves the interior angles formed by parallel lines and a transversal. Prove your conjecture. So at this point, we're just following along. You don't need to write anything in your notebook. We're going to summarize this later. So Tayet had a conjecture. He said that when transversal intersects a pair of parallel lines, the alternate interior angles are equal. So we said interior angles were all the angles inside parallel lines. What we're looking at now is we're looking at alternate. So two non-adjacent, two non-beside interior angles on opposite sides of the transversal. So that's what we're looking at here. We're looking at these alternate interior angles. He is going to prove, so he's set up a beautiful two-column proof here. First of all, it says I drew two parallel lines and a transversal is shown, and I numbered the angles. I need to show that 2 equals 3. Since I know that the lines are parallel and the corresponding angles are equal, he could say angle 1 is equal to angle 2, because that's corresponding angles. And his justification is because we've already shown corresponding angles in the last section, he used that as his justification. Then he said angle 1 is equal to angle 3, right here, because of vertically opposite angles. And finally, he said angle 3 is then going to be equal to angle 2 due to the transitive property. So that was, I believe Mrs. Schmall went over with you, when A equals B and B equals C, then we can say A equals C. That's called the transitive property. So therefore, he has proved this conjecture. Okay, and then we have Allie came in and she made a conjecture. Now I don't like her proof as much. It's not a formal two-column proof. We're going to practice more formal proofs, but she could have done this in a two-column proof. She says when a transversal line intersects a pair of parallel lines, the interior angles on the same side of the transversal are supplementary, and supplementary means adding up to 180 degrees. So she needs to show that angle 3 and angle 5 are supplementary, since those are interior angles and they are on the same side of the transversal. Since the lines are parallel, the corresponding angles are equal. So angle 1 equals angle 2. And these angles form a straight line, so they are supplementary. So 2 and 5 are on a straight line, so they have to equal 180. Since 2 equals 1, I could substitute 1 for 2 in the equation. So instead of 2, since it equals 1, she could easily substitute in there. So angle 1 plus angle 5 is equal to 180. She said that vertically opposite angles are equal. So 1 and 3 are vertically opposite. So she could substitute 3 in for 1. So she showed that angle 3 plus angle 5, or these interior angles, these on the same side of the transversal, she showed that they added to equal 180, or were supplementary. And she has proved her conjecture. Okay, we are now going to do another conjecture. We are going to prove that alternate exterior angles are equal. Alternate exterior angles. Okay, so we are going to do a two-column proof. with our statement and our justification. Okay. So what we're looking at here, and you might want to draw this in the corner or somewhere on your sheet, is we are trying to prove that alternate interior angles are equal. So let's look right here. If we had 1, 2, this is very small, I'm sorry, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. So draw this diagram bigger in your diagram. So we need to show that angle 2 is equal to angle 7. Okay, so first of all, we're going to show that we're going to say that angle 2 is equal to angle 6. And the reason for that is because since lines are parallel, the corresponding angles are equal. Okay. Now we can also say that angle 6 is equal to angle 7 by vertically opposite angles. Vertically opposite angles are equal. So since we've shown that 2 is equal to 6 and 6 is equal to 7, we can say angle 2 is equal to angle 7 by the transitive property. So we have proved that that alternate exterior angles are equal. Okay, I want you to read through this example 2 in your book using reasoning to determine unknown angles. So press pause, read through this. This is a really good example, just like questions you're going to do in your text. So press pause, do that. Once that's done, what needs to go in your notes is you need to summarize this information here. Now that we have proven all of these things, they can be used in any proof that you are going to use. So you can use that alternate interior angles are equal. You can use that in any proof that you're going to do. So press pause. I want you to summarize this information in your notebook. Be sure to have this great diagram. And your assignment is number 1, 3, 10, 12, 13. You need to actually construct with geometry set. And number 16. And my hint for 16 is to draw separate diagrams, extend lines, sketch it out. Okay, you will have some time at the beginning of next class to finish this work. Yes, and good luck. I will see you guys on Friday.